Good morning, everyone. I think all I have to speak is about my industry and then play the video on fast-forward mode because 90% of the words, the workflow is going to be repeated. It's so common. Get the data, play through the application, use LLM. I love it. I think the key message at the end of it is the power of the framework and the power of accessibility of this framework. Remember these two words? These are not prepared. That's what I'm learning today. Okay. I'm Shailesh Sharam. Yes, you heard right. I manage the business intelligence, which is innovation, as well as cybersecurity, which is governance and risk management. I'm from CPKC. CPKC, on April 14th, we marked an iconic day of merging two big, giant historical railroads together, that is Legacy CP and Legacy Kansas City Southern. We now operate, or the only single-line railway operating in Canada, US, and Mexico, with 20,000 miles of network. What we're going to talk about today, again, very briefly, we built a solution around network management, and potentially the biggest users is service designers. Before jumping into what we are trying to do, how many of you wondered seeing a train pass by and thought about where are the cars coming from and going to? And imagine someone is wondering about 80,000 such cars every day. 80,000 such cars with 3,000 stations, 5,000 customers day in and day out. And there is a method to madness. And we call it precision scheduled railroading. That is a power all the railroads use. I have my fellow railroaders here. We have a love and hate relationship. Don't find any false plays. OK. So the architects of this precision scheduled railroading starts at the design. We have a design how to run the trains. They create order in this chaotic world by giving a unique mission for every car, one car at a time. Where does it start? Where does it go? Which route it takes? What is the best possible way to run the railroad, serving the customer with the minimal cost? Sounds so simple, right? So, so there are a lot of metrics, a lot of measures which go into the mix, and some are publicly disclosed, some are internally monitored. We are going to talk about one such problem of managing dwell. Again, in a simple terms, dwell is how much time a car is spending in a yard. Yes, it is supposed to spend time, but how much is it planned versus actual? What makes this problem complex is if you're not managing the dwell, if you're not managing the volume of incoming cars into your station right, you're not only impacting the cost and performance of your station, but you're also going to impact the incoming trains and outgoing trains, thereby entire network. And this is an age-old problem. Frankly, every railroad has this problem, and it has been the standard optimization problem for any logistics company: first mile, last mile, yard management, plant management. One day, that's what innovators are promising us, that there is quantum computing out there. All we have to do is throw the data. It'll give us what to do. I think it's 10 years, 15 years ahead of us, for sure. What we're doing now is, again, stealing the words, AI-powered decision support system. We are not trying to recreate the world, means eating the entire apple, but chunks at a time, taking one problem at a time, take our data, forecast what's going to happen proactively, and give power to the user to make informed decisions. So we are using the Palantir platform to attempt that. So the challenges, as I mentioned, is it's a multivariate statistics problem, typical OR, operations research problem. And every logistics company is different. On top of that, every railroad is different. We run with different principles, different geographies, and different traffic mix. But coming to IT, the biggest challenge is how do we connect business to the models? What I mean is, how do we encode the business knowledge? Not only one time when we build the applications, but incrementally as the business changes and evolves. The second problem, and the toughest problem, I think someone already spoke today, is how do we get those models to business? How do we let them adopt and adapt to these technologies and trust them and not make the technologies obsolete? We hope we have found a formula to do that. We have done it in various ways in technologies, and this is another attempt. And I believe we cracked the formula this time. So we love maps, railroaders, all the railroaders. So here we have our CPKC network in 3 countries. And we already loaded our data into our ontology, 10 years of history. We have a forecasting model running on the same platform telling 5 days to 14 days out where could be the potential problems. And these are all the alerts, and a user, whether it is service design user or an operations user, can proactively see what could happen 3 days from now. And again, there is a math and science to it. Math is you have something coming your way, all you're saying is when is it coming. Science is how do you put external factors in? How do your historical performance in? How do you say what happened when there is a snowstorm in the east? How is it going to impact the west? I think all those models are running in the background to give this prediction. I'm not going to show that today. Assume we are starting with the alert, and this is Aelith, a station near Calgary, one of our key junction coming into the west. So what we can do here is we can zoom in and exactly find out what's happening at Aelith and what is the alert saying. In a nutshell, you have some numbers there. What is the average dwell? What is leading to the alert? It is 44.2 hours it is predicting. Again, it is notional data. Please do not tell any analyst on anything. We are all perfect. OK. So what we're doing is, OK, no one, executives or decision makers wants to know what is truth behind it. So we give the trend. And there are a bunch of screens which are not visible in the video, but historical actual volumes and historical actual dwells so that they can link back to operations. And then the next question is, how do I address and solve this dwell proactively? And remember, this is all 2 days out or 3 days out. So the traffic is already en route to you. It's not that you can stop the traffic. Some of it is already coming. Some of it customers are about to release. So what we ask in the next step is the co-pilot, agent, whatever we call, but the AI agent to say, can you find a solution to me? And this is where the magic is. As I think Brian spoke, we already encoded some intelligence. We are asking some questions. Build a plan to reduce dwell Aelith. And let it run. And it is computing. But what is critical here is we have not loaded our entire intelligence yet. We have loaded some of the levers which we have in control while the traffic is en route to reduce the dwell. So with the knowledge we shared into the bot, it has come up with a plan. Again, it has 2 steps. Build a bypass block and hold a train. In a nutshell, the first step is saying, make sure the traffic is not getting worked in this station. Do the work ahead of time. Second point is saying that, OK, there is a train which is about to start 800 miles away. Stop that for 14 hours so that I can clear my yard and make smooth operations. I might like it. I might not like it. But the difference here is whether it is a new service design user or an experienced operator, you're already coding the core fundamental business metrics into it. Whether he looks at it or not, whether he or she chooses to acknowledge it or not, we are showing the local impacts as well as the global network level impacts. That is the power of AI. When people say that it is going to pre-calculate and share it with you, it's up to the human. And next step is, I think, we like the model or we don't like the plan, what it is building. And we are trying to simulate, yes, show me the results of your plan. It showed that, OK, the dwell is reduced by 2 hours, but it is comparing the base scenario with the new scenario put in, and it is showing the metrics so that we can challenge what is the cost. We are only showing 2 metrics or 3 metrics here, but eventually imagine you're showing the cost metrics, operations metrics, as well as the commercial metrics to it. So the next step what we built is good. We have one suggestion. We choose to take it or ignore it. But we are saying what is the impact of this decision overall. And here there is a complex chart, too small to read. In a simple nutshell, on the left side, you have all the stations which these trains or the suggestions are going through. Each blue block is an amount of work. What it is telling me is at the St. Paul, it has 3 yellow boxes. And those 3 yellow boxes are extra work someone else is doing to help me recover from my traffic congestion. And I saw the summary of it. Basically, it is saying you have to build 2 more blocks. Blocks is nothing but a group of 10 cars, 40 cars, or 100 cars, sometimes if it is a unit train. But I know as an experienced railroader, St. Paul is critical. I cannot put more work at St. Paul. So I can go back to the co-pilot and challenge, what can you do by ignoring St. Paul and by not giving more work to St. Paul? So that's what we're going to do here. I think I skipped it. So. OK, so we put another constraint. I think the key here is I can repeat it again and again. But The model has been trained by pre-existing levers, but now you're also taking real-time information from the operator and including it in the modeling and scenario. But it's not only one time. You're capturing what was the problem, what was the user doing, and what kind of scenarios he's running with it, and what was the result of it. All of it is stored back into the ontology, into the knowledge base, where we can, or whether the same person or a different person can refer back to, and this is what is called building the knowledge base for the future. And then we know exactly which levers are impacting, how much they are impacting, what is model-driven versus what is operator-driven, what is data-driven technologies. So now we regenerated another solution. It is simulating, and we are also saying, what if I threw in more crews and more locomotives? We added this third scenario just to explain adding more crews and adding more locomotives is nothing but adding more cost. That is the last option we want to choose as railroaders is, again, PSR is run an optimal railroad with all the optimal resources. So if you're adding more crews, more resources, it might be beneficial only for certain points, but not all the time. So the model goes back, calculates, and shares with you the cost impacts as well as the operational impacts of the decision. And imagine you ran 3 scenarios in a nutshell, and the end user is able to say what are the results of each scenario, but not only for once. All the scenarios, all the results are stored forever for this metric, for this particular station. All I have to do it for 2,000 more stations across North America. And each station is unique, and each journey is unique, and we are embarking on a journey. It's not a one-time solution, but we are encoding intelligence piece by piece into this process. What I like, again, is the framework. We are building digital twins of the data. We are including the forecasting models on top of the data in the same platform. We also giving LLMs or easy way to interact with the models and the data by taking real-time inputs. In a nutshell, we're building for the future on a platform where we think it is scalable for the future. That's what we are doing at CPKC. And again, it's notional data, Mr. Railroaders. Elite is perfectly fine, and we are right on the right track. Thank you.